Today we're going to be solving exponential equations. So your essential question is, how do I cancel out a base to bring down an exponent in an equation? So we're going to test out how to solve these types of equations. There's two basic types that we're going to focus on today. The first is solving by equating exponents. So that means that we want to make the exponents equal to each other. So in order to do that, I have 4 to the x power equals 1/2 to the x minus 3 power. So what I would have to do is make it to where if I have, like, let's say I have 3 to the 3rd power equals 3 to the x power. Well, because my bases are the same, I know what x equals in this scenario. This means that x equals 3 because my bases are the same, so that means that 3 to the 3rd power has to equal 3 to the 3rd power, so x has to be 3. So if I make my bases the same number, then I can make the exponents equal to each other. So I need to figure out what number can I use for 4 and 1/2 as my base. So what number can be taken to a power and equal 4, and also take that number to a power and equal 1/2. So the answer is 2 in this case. So if I use 2 as my base, 2 to the what power equals 4? Well, that would be 2 squared. So I would take 2 squared and I replace that with the 4. Well, there's already an x in the power there. So I have 2 to the 2x. And then equals, and then I have, I'm going to erase this other equal sign here so it's not confusing. Now I have 1/2. So 1/2 would be like 2 to the what power? How do I make a number become a fraction using powers? So to get a fraction, I would have to use a negative power. So this would be like 2 to the negative 1st power. And the x minus 3 is already there, so I want to leave it there. So now my 2's are the same. So I know that 2 to the 2x power has to equal 2 to the negative 1 times x minus 3 power. So these powers have to be the same. So basically I can get rid of the 2's because I know that 2x has to equal negative 1 times x minus 3. The exponents have to equal each other since 2 is my base. So I'm going to distribute this side. So I get 2x equals negative x plus 3. And I'm going to solve for x. So I have x's on both sides of the equal sign, so I need to cancel one of them out. So I'm going to add x to both sides. There's multiple ways to do this. So I get 3x equals 3. And so I'm going to bring this over here. 3x equals 3. If I divide by 3, then x would equal 1. So that's my answer. Okay, let's take a look at another example. So feel free to pause the video and try this one on your own if you would like to. Let me cover this bottom one up so that you can kind of try it on your own, and then you can check and see how to solve it. So 9 and 27. I have to make those powers of the same base. So what number could I use? I take a number to a power, I get 9. I take that same number to a power, and I get 27. If you aren't sure, you can always just guess and check. So, like, I'm going to try 4. Well, 4 to something power doesn't equal 9, so I can't use that. So I'm going to try 3. So 3 to the 2nd power equals 9. So this would be basically like 3 squared as I'm replacing 9. And then I already had the 2x there. Okay. And 27 is like 3 to the 3rd power. So I would have 3 to the 3rd power to replace the 27. And the x minus 1 is already there. So because these are both the same base, the exponents have to be equal to each other. So I get 2 times 2x is equal to 3 times x minus 1. So 2 times 2x would be 4x. And then if I distribute this side, I would get 3x minus 3. So I would subtract 3x to get x by itself. So I get x equals negative 3 as my answer. All right, I have one more example on here for you to try. It's the same concept. So we have to have 81 and 1/3 be powers of the same base. So what number to a power can equal 81? And I can use that same number to a power and get 1/3. So if I look at 1/3, I know there's probably going to be a 3 involved there. But how do I get 1/3 by using 3 as a base? So 3 to what power equals 1/3? Well, to make a fraction, I have to have a negative exponent. So this would be 3 to the negative first power. And I'm going to leave the 5x minus 6. And then 81 would be like 3 to the fourth power. And I'm going to leave the 3 minus x. So now my bases are the same, so I can basically get rid of those. And I have 4 times 3 minus x equals negative 1 times 5x minus 6. So on this one, I have to distribute both. So I would get 12 minus 4x equals negative 5x plus 6. And then since I have x's on both sides, I want to cancel one of these out. I'm going to cancel out the smaller one, but it really doesn't matter. So if I add 5x to both sides, I get 12 plus x equals 6. So I'd subtract 12 from both sides. So I get x equals negative 6 as my answer. All right, so that's how we solve equations by equating the exponents. We make the bases the same. Okay, the other type of question that we're going to solve today is by taking the logarithm of each side. So if I have 4 to the x power, we kind of talked about inverses in one of the previous sections. If I was to rewrite this in logarithmic form, then I could kind of solve it for x, but it might be kind of hard to figure that out. You could use the change of base formula and do it that way, or you could just take the log of both sides to cancel it out. Well, if we look at our base is 4. So I would have log base 4 of 4 to the x in order to cancel out the 4 as the base. So to cancel out a base, you have to take the log of that base of both sides to cancel it out. And so I also have to take the log base 4 of this side. I can't just do one side and not the other. You have to do the same thing to both sides. So the log base 4 and the 4 cancel each other out. So I get that x is equal to log base 4 of 11. So I don't know what this is because 4 to the something power equals 11, but I have no idea what that would be. It would be a decimal. So I would have to take the log base 4 of both sides. Well, I did that, and then I'm going to do the change of base formula to work this out. So if I rewrite this, remember I put the base in the basement, so I would have log 11 divided by log 4 if I use the change of base formula. So the base goes in the basement. So if I work that out in my calculator, I should get about 1.73 if I'm rounding to 2 decimal places. So make sure to do that in your calculator and check to make sure you get the right answer so you don't have it wrong for the test. Okay? So another way to think of this is essentially what I just did is I rewrote this in logarithmic form. So really, remember if I have base, power, answer, okay? Remember to write it in logarithmic form, I'm supposed to do back. So it's base, answer, power. So that would be log base 4 of the answer, which is 11, equals the power, which is x. So that's basically what we just did over here. So that's another way to think about it if that confuses you. Okay, I want you to try another one. So you can feel free to pause the video and try this problem. Okay, so we're trying to cancel out the base of 7. So what cancels out base 7? Well, the opposite of base 7 is log base 7. So I would have log base 7 of 7 to the 9x equals log base 7 of 15. So I just took the log base 7 to both sides to cancel out my base of 7. So the log base 7 and the base 7 cancel out, so I just get 9x equals log base 7 of 15. So if I want to get x by itself, I have to divide by 9. But first, I need to figure out what this part equals. So what I'm going to do is I'm going to rewrite that using the change of base formula. So remember, the base goes in the basement, so this is going to equal log 15 over log 7. Now, remember, you can use that answer button in your calculator. It's going to come in really handy right now. So if I'm working this out in my calculator, I'm going to go ahead and do the right-hand side. So I'm going to take log 15 divided by log 7, and I get 9x equals about 1.39. Now, don't erase what's in your calculator. It's like 1.3916622509. So leave that whole number in your calculator, and we're going to go ahead and divide that by 9 to get what x equals. So leave the whole thing in your calculator and divide it by 9. So we get about 0.15 if we round to 2 decimal places. All right. Another way that you can think of this is if you rewrite it in logarithmic form. Remember, this is the base, this is the power, this is the answer. So it would be like log base 7 of the answer, 15, equals the power. Remember, BAP? So it ends up coming out to be the same thing. It's just written backwards. So you can do those problems either way. Okay? Thank you. Make sure you go back and answer the essential question and write your summary.